Hello everybody, welcome to video 12 section 5 lecture 1 subnetting class B. Now we are in subnetting class B. Subnet mask versus CIDR notation for class B. CIDR stands for classless interdomain routing. So subnet mask of 255.255.0.0 is the default subnet mask and its equivalent CIDR notation is /16. So these two are the default values for class B. Likewise, if we borrow 1 bit, then this is the corresponding subnet mask. We have already seen this from 17 through from 25 through 30 in class C subnetting. Now in class B subnetting, it starts with the third octet. So in third octet, if you borrow 1 bit, then it becomes 17 bits. Likewise, if you borrow 2 bits, this is 18 bits. On borrowing 3 bits, it is 19 bits. If you have a close look over here, you will find that the magic numbers are same. So in octet 4, when I borrow 1 bit, the magic number is 128. So these magic numbers are 128, 192, 224, 240, 248, 252. The same is over here. So this is about the fourth octet, this is about the third octet. So this is in the third octet: 128, 192, 224, 240, 248, 252, 254, and then 255, because we cannot use /31. We have already seen this in class C. So the magic numbers are all same regardless of which octet you are in. The formula is same. Number of subnets or number of networks is equal to 2 to the power bits borrowed. So in this case, we are looking at what happens when we borrow 1 bit. So we have same 2 subnets. Number of hosts formula is same, 2 to the power host bits minus 2. Now in class B, the default is /16. So we have got 16 bits for the host portion. So from the 16 bits, 1 bit is borrowed. So 16 minus 1, 15. Whereas in class C, it was in the fourth octet, and there were 8 bits for the host. So when 1 bit is borrowed from the host, so 8 minus 1, 7. But over here, 16 minus 1, 15. And we get the corresponding number of hosts per subnet. The magic number, now this magic number is in the third octet. Remember, these magic numbers are same. And we will also have the same block size. The only difference is in which octet we are playing, or in which octet we are looking at. The new subnet mask, now it depends upon the magic number. So because this is in third octet, so what will happen? The new subnet mask, the change will be in the third octet only. Now block size, what does block size give us? The block size gives us the next subnet value. So first subnet is 0, 0, second subnet will be 128, and that will be in the third octet. So the two networks are 0 and 128, but this 0 is in third octet and 128 is also in the third octet. 1 less than the second network will give us the first network's broadcast address. Remember, 1 less than this will not be 127, because we have got, this is the network portion only. So 127.255 is what we get after subtracting 1 from here. So 1 more than the network address gives us the first valid host. 1 less than the broadcast address gives us the last valid host. So these are the valid host addresses in first subnet. These are the first valid host addresses in the second subnet. Exactly same that we did in class C subnetting. Case 2, when we borrow 2 bits, we have got 2 power to 4 subnets. The number of hosts will be, there are 16 bits for the host. So 16 minus 2, 14. And that comes to 16,382. And then find the magic number, because we borrowed 2 bits, so it is 11000000 in the third octet. This gives a decimal 192. Now from here we find the block size. So block size formula is 256 minus magic number. So it is 256 minus 192, which is 64, and this block size gives us the next subnet. So next subnet will be 64. So the first subnet is 172.16.0.0. So next will be in the third octet, 172.16.64.0. And from this magic number we can also find the new subnet mask. So this is also in the third octet. So 16.0, this is the 0 is the third octet, so 64, because the block size is 64. So 64 plus 64, 128. Again 128 plus 64, 192. If we add 64 to 192, it becomes 256, and 256 is not part of 8-bit octet. So maximum is 255. That is why we get this 255 as the broadcast address. The same rule applies. 1 less than the second network address will give us the first broadcast address. Likewise, 1 less than this will be the broadcast address for second subnet, and so on. 1 more than the network address means first valid host. 1 less than the broadcast address means the last valid host. Anything in between these two will be the valid host addresses. So exactly same thing, whenever we borrow 1 bit or 2 bit or 3 bit or 4 bits, whichever class it is, borrowing 1 bit always gives us 2 subnets, borrowing 2 bits always gives us 4 subnets, borrowing 3 bits always gives us 8 subnets. 4 bits borrowed means 2 power 4, 16. Borrowing 5 bits means 2 power 5, 32 subnets. So the same formula applies. It only depends upon which subnet we are which octet we are looking at. So when we borrow 3 bits, we get 3 networks or 3 subnets, and number of hosts 16 minus 3, 13. So this is what we get, number of hosts per subnet. Find the magic number. Now because we borrowed 3 bits, so 111, the first 3 bits will be 111 each, and then this is the magic number 224 in the third octet. Block size 256 minus 224 is 32. So now the block size will be 32, and we get the new subnet mask. This 224 comes in the third octet. So now what will happen is 16.0, so this will be 32.0. So 172.16.32.0. I don't have much space over here, that is why I have written. This is 172, this is the third octet. So 172.16.0.0, 172.16.32.0, because the block size is 32. So 32 plus 32 is 64. So this is actually 172.16.64.0. This is 172.16.96.0, and so on. So this is the third octet, this is the fourth octet. And if I subtract 1 from here, this becomes 31.255. So this is the broadcast address, and everything in between these two would be the valid host addresses. So these are also valid host addresses. So first, second, third, fourth, fifth, sixth, seventh, eighth subnet. So totally there are 8 subnets. Now if we count them manually, they will come to 8190. Now we are in the third octet, block size is 32, and the new subnet mask for each of these networks will be 255.255.224.0. So each of this subnet will have the same subnet mask. So that's all for this particular video. In next video we will continue our subnetting in class B, because I don't want to make this video very lengthy. So see you in next lecture. Bye for now.